So far, we've been doing limiting reagent, also known as the limiting reactant problems that started off with moles of the reactants. In this video, we're going to start off with grams of the reactant. So in this scenario, 3 hydrogen gas plus 1 nitrogen gas forms 2 ammonia gas. Based on this balance equation, you're going to see if there are 1.70 grams of hydrogen, 3.00 grams of nitrogen, how many moles of NH3 will be produced. So we start off with 2 different values of the reactant. I'm going to go ahead and write that as 2 different values, 1.70 grams of H2 here, and then 3.00 grams of N2. From this reactant here, I want to solve the stoichiometry problem so that in the very end, I would get moles of NH3. Same thing for the second row. I want to calculate a bunch of stuff here so that in the end, I would get moles of NH3. In order to do that, the very first thing we want to start off with is the molar mass. So for every 1 mole of H2, you would have 2.02 grams of H2. Why did I need to start off with the molar mass? That's because I want to get rid of the grams of hydrogen. Now let's go into somehow we need to convert this moles of hydrogen into the moles of ammonia. That in this scenario, we would have to use mole to mole ratio. So balance equation shows us that 3 moles of H2 will produce 2 moles of NH3. That means I could cancel the moles of H2 and I'm done because I stop here because I want my final unit to be moles of ammonia and my final unit here is ammonia and that cannot be canceled. So we're going to calculate this out and then find out how many moles of NH3 this is produced. 1.70 times 1 times the 2. So I'm multiplying everything that is on the numerator. And then I'm going to hit enter and then divide that by parentheses 2.02 times the 3. Everything that is encapsulated on the bottom. And that equals to 0.561. 0.561. You're going to do the same setup, but now you're going to take nitrogen. Try this setup and come back and check the key. And here is the key. 0.214 is selected over the 0.561. This is because you want to choose the one that has a lesser product value. The next question is, which reactant is the limiting reactant? You have 2 choices. H2 is a reactant and so is the N2. So which one is the limiting factor? The one that produced less is going to be the limiting factor. Where it came from? It came from the nitrogen. The limiting reactant is not the NH3. That's your product. The limiting reactant should come from the reactant, which are one of these 2. And since the nitrogen produced less moles of the NH3, that nitrogen is the limiting reactant. So this is N2. What is in excess is the other gas, which is the H2. Here is another learning check problem. I'd like for you to try this on your own and come back and check the key. And here is the key. Now, in this limiting reactant problem, it starts off with the grams of reactant, just like the previous problem, but it's going to end in grams of the product. Last time, it ended in the moles of product. This one, it's going to end in grams. So there will be additional step. So let's start from here. If there are 4.70 grams of hydrogen, 9.50 grams of nitrogen, how many grams of NH3 will be produced? So I have 3, not 3. I have 4.70 grams of H2 and 9.50 grams of N2. I'm going to do a series of calculations so that in the end, I am left with grams of NH3 for the starting value of the hydrogen and for the nitrogen as well. So let's begin with the molar mass of hydrogen, which is 2.02 grams of hydrogen for every 1 mole of hydrogen. Then we get the mole-to-mole ratio, and the mole-to-mole ratio shows that every 3 hydrogen in moles, there's 2 moles of ammonia. Because we're going towards the direction of the grams of ammonia, we want to incorporate more mole-to-mole ratio that involves ammonia. So every 3 moles of H2, there are 2 moles of NH3. And that cancels out the moles of H2. Now, I am not done yet because I am left right now with moles of ammonia, but I want grams of ammonia. In order to do that, you're going to go ahead and do the molar mass. For every 1 mole of NH3, well, what is the molar mass of NH3? It is 17.04. Okay. So that cancels out moles of ammonia, and I'm left with grams of nitrogen. Let's calculate this out. 4.70 times 1 times 2 times 17.04. So I have multiplied all the values that are on the numerator. Then I'm going to divide that by all the multiplication on the denominator with the parentheses times 3 times 1, and that will give me 26.4 grams of ammonia. So you're going to do the same or very similar step on the next one, but instead of the molar mass of hydrogen, you're using the molar mass of nitrogen since we're dealing with nitrogen. Try that and come back and check the key for this bottom row. So here's the key for the bottom row. In fact, the bottom row is the correct one, that 11.6, that's the ammonia that will be produced, not the top one. We want to choose the one that has the lower value. Now, you won't know which one has a lower value until you calculate the whole thing. It has nothing to do with what your starting value is. Look, the starting value of nitrogen is 9.50, so you might think that might be the excess in comparison to the 4.70 of the hydrogen, but rather nitrogen is the one that is limiting. It's the one that will produce less amount of ammonia. So what is the limiting reactant in this scenario? This scenario, the nitrogen will be the limiting reagent or limiting reactant, and the in excess would be the hydrogen. Let's try a learning check. Please try this, come back and check the key. And here is the key.